We'll experiment with this a little bit. Probably be better. Usually I'm too close to the mic. Gets too much feedback. Sounds bad. Okay. This is not the book. Here's the book. Let's put that over here. This doesn't really matter. Okay. So today, the next 5 sections that we're covering are all on linear equations. A linear equation is some equation where the variable has a single exponent. This is a general form of a linear equation. Something like ax squared plus b equals c. This is not a linear equation because we have x squared. Square root of x equals c is not a linear equation. The square root of x can be expressed as x to the 1/2. A linear equation is an equation where the variable is raised to a single power, a single exponent, x to the 1, which is the same thing as just x. So that's what we mean by a linear equation. So we're going to start out by solving linear equations. Here's a concrete example of the types of equations you're going to be solving. 4x plus 16 equals -5. Your job is to find the x that satisfies that. Now you can keep thinking in your head, plugging in numbers. Oh, let's see, if I plug in -3, 4 times -3 is -12, plus 16, that gives me 4, not -4. Maybe -4 works. 4 times -4 is -16. -16 plus 16 is 0. Oh, that didn't work. Maybe -5. 4 times -5 is -20. Plus 16 is -4. -5 works. X equals -5. That's a special number I can plug in here to get a solution. Any other number I plug in doesn't work. Now, guessing a bunch of numbers and plugging in is a very stupid way to solve this. A much better way to solve it is to isolate this x. You want to get the x by itself on one side of the equation and everything else on the other side. So it's going to be about isolating variables. So first thing, what do we do? Subtract 16 from both sides. It's the equation. What we do to one side, we have to do to the other side. So I can subtract 16 from this side and subtract 16 from this side. All right. Over here we get 4x. Positive 16 plus -16 gives me 0. So I'm left with 4x over here is equal to -4 minus 16 is -20. Good. All right. So now we got that. Now what do we do?
Divide by 4.
You got the right idea. I'm always going to say multiply both sides by 1/4. The same thing as dividing by 4. What does it mean to divide by 4? It means to multiply by 1/4. I always think about it this way because it stops me from making dumb mistakes down the road. So I'm going to multiply both sides by 1/4. If 20x is equal to -20, then 1/4 of this has to be equal to 1/4 of this. Right? Makes perfect sense? All right, what is 1/4 of 4? 1. That's why we chose 1/4. 1/4 times 4 is 1. 1 times x is x. So we got the x by itself. That's why we multiplied both sides by 1/4. That was the whole point. Okay, now we got -20 times 1/4. Or in other words, -20 over 4. However you want to think about that. 5 or -5? -5. Because a negative times a positive is a negative. A negative times a negative is a positive. Remember, if there's an even number of negatives being multiplied together, it's positive. If there's an odd number of negatives being multiplied together, it's negative. Quick check. What is -1 to the power of 57 equal to?
-47.
-1. We're talking about -1 times -1 times -1 times -1 times -1, 57 times. So -1 times -1, well that's 1, times -1, now we're at -1, times -1, well now we're at 1. Keep going 57 times. If there's an odd number of negatives, the answer comes out negative. Let's really test it. -2 to the power of 6 is equal to?
2. A positive.
A positive what? No, now you're counting by twos. We need to multiply by 2. What's 2 times 2?
4.
Times 2.
8.
Times 2.
16.
Times 2.
32.
Times 2.
64.
You did it. 64. Right? And it's positive 64 because we had an even number of negative 2's. This was the same thing as negative 2 times 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 negative 2. That's what we mean by negative 2 to the 6. That 6 times. So it's the same thing as just 2 to the 6. And then we don't add the negative because there's an even number. One more check. What if that was a negative 7? Or a 7, I mean. We won't do negative next one.
Negative 66.
But no.
No.
It'd be negative 128.
Negative 128. So we knew that negative 2 to the 6 was equal to 64. Let's double 64. 128, and then make it negative. What if it would have been to the 8?
You just do that again.
Then it would have been positive 256. If it was 9, it would have been negative 512. If it was 10, it would be positive 1024, etc.
How do you just know that?
Yes, I didn't know this. They called me a math teacher, and then I knew it. Okay. So, that's a little bit of recap from last time. In general, here's what you do. For any equation, any linear equation of the form ax plus b equals c, where b and c are any numbers, what are we going to do? We're going to subtract b from both sides.
Always.
And so then we're going to get ax is equal to c minus b. And then we're going to multiply both sides by 1 over a. I'm going to multiply by 1 over a. Do the whole thing. I'm going to take the whole thing and multiply by 1 over a. Not just one term. 1 over a times a is just 1. 1 over a times a is 1. 1 times x is x. So we get x is equal to c minus b all over a. That's always and forever how you do these. When it's just a single variable formula like this. That's what we did over here. We subtract 16 to both sides, then we divide it by 4. Subtract b to both sides, then divide it by a. Or multiply by 1 over a, same thing. That's the general pattern, that's how we always do it. So now, let's go through some of the author's examples and just solve them. Let's see. So here's this first example. We already did that one. Saying plugging in 3 doesn't work. Surprise, surprise. Okay, let's do this one. So we have x plus 7 equals negative 5. What do we do first?
Subtract 7 from both sides.
Subtract 7 from both sides. So x plus 7 minus 7 leaves me just x. Negative 5 minus 7 minus 12. So x is equal to minus 12. All right, let's do all these examples. 4 plus x is equal to 8. What are we going to do?
Minus 4 from both sides.
Minus 4 from both sides, and we get that x is equal to
4.
4. Fantastic. 7 is equal to x plus 9.
Or negative 2.
7 is equal to x plus 9.
Subtract 9 from both sides.
Subtract 9 from both sides.
Negative 2 equals 7.
So 7 minus 9 is negative 2 is equal to x plus 9 minus 9 just leaves us x. Wonderful. And then finally over here, 5 is equal to 8 plus x.
Subtract 8.
Subtract 8 from both sides, and we get x is equal to
Negative 3.
minus 3. Wonderful. Let's double check. 4, negative 2, negative 3. Woo. We did it. Okay. We'll do these 3. So now we have negative 6 plus x equal equal to negative 2. What do we do?
Add 6 to both sides.
Add 6 to both sides. I want to get rid of whatever is next to the x. I want the x by itself. So I need to get rid of this. How do I get rid of the negative 6? I add 6. But what I do to one side, I have to do to the other, otherwise it's not equal anymore. So we're left with x here is equal to 4. Fantastic. On this one, what are we going to do?
Add 7 to both sides.
Add 7 to both sides. So negative 10 plus 7 is?
-3.
Negative 3. Negative.
Sorry, guys.
All right. And then finally, this one. What are we going to do?
Add 8 to both sides.
Add 8 to both sides, so we get x is equal to 13. All right. And then dividing by variables. Let's just go to if they have 3 examples listed out. Perfect. Okay. Over here, we have 8x is equal to negative 24. What are we going to do?
Do 1/8.
Multiply both sides by 1/8. Or divide both sides by 8. However you want to think about it. What's 1/8 of 8? 1. Times x is just x is equal to, what's 1/8 of 24? 3. So this is the same thing as negative 24 over 8. Negative 24 over 8 is?
Is it negative?
Negative 3. A negative times a positive is?
Negative.
Negative. So we get negative 3. Fantastic. So x is equal to negative 3. Let's do this one. We have negative 4x is equal to negative 20. What are we going to do?
1/4.
Divide both sides by minus 1/4, or minus 4. Times both sides by minus 1/4, or divide by negative 4. However you want to think about it. The negative 4's go out, leaving us with just x is equal to negative 20 divided by negative 4 is?
5.
Positive or negative?
Positive.
But those are negatives. Positive. Don't backtrack. Don't backtrack. There's 2. A negative times a negative is a negative. There is a positive. Thank you. That one was a mistake, but before, I did it on purpose. Okay. This one, 42 equals 7x. What does x equal?
7.
What's 42 divided by 7?
6.
6. Ah, you must be doing good on those drill sheets. See how knowing some basic arithmetic can save you writing a lot of stuff? All right. Let's do this one. So I have x divided by 5 equals negative 3. So x over 5 equals negative 3. I need to get the x by itself. How do I get rid of the 1/5 over here? What? Multiply by 5 over 1. 5 is equal to 5 over 1, so same thing, right? So multiply both sides by 5. 5 times x over 5 is equal to? 5 over 5 is equal to? 1. So the 5 cancels out with the 5 right there, leaving 1 and 1. Okay. So we get x. That was the whole reason we multiplied by 5. So coming back, when we are looking at this, we are looking at x over 5 equals, oh shoot, what was our number? Minus 3. Okay. What we're doing is we're looking at this because we're trying to say, how can I get rid of that 5? I'm trying to figure out what I can multiply this by to get rid of that 5 and get x by itself. That's the whole reason we chose 5. The whole reason we chose 5 is that when I do 5 times x over 5, I'm left with just x. Because 5 over 5 is 1. That's the whole reason we chose 5. Okay. So that's equal to negative 3 times 5, which is equal to?
Negative 15.
Negative 15. Yeah. All right. Let's do each of these. So I have x over negative 7. X over negative 7 is equal to negative 2. What am I going to do?
Times 7.
By
Both sides by negative 7.
by negative 7. Not positive 7, negative 7. Same exact number that we have here. I'm going to multiply by negative 7 here. I'm going to multiply by negative 7 here. Negative 7 over negative 7 is equal to 1. So we're left with the x by itself. Is equal to 14. Fantastic. All right, next one. We have x over 8 equals 5. So x equals 40. Just multiply both sides by 8. And you get x is equal to 40. Wonderful. Next one. We have x over negative 4 equals 9. Times both sides by negative 4, and we get x equals negative 36. Fantastic. Feel like we got these?
Yeah.
All right. That's section 1.1. Easy as pie. Section 1.2. Just forcing us to do 2 steps in one go. Okay, so let's see if there's a place where they don't give a bunch in one go. So, let's pick one go. All right, so now we have 5x plus 7 is equal to 7. Trying to get the x by itself. What am I going to do first? Minus 7 from both sides. Fantastic. So minus 7, minus 7. And what are we left with? 5x equals what? 0. Fantastic.
Divide by 5.
Divide both sides by 5. And we get x is equal to what?
5.
0 divided by 5 is
0.
0. Remember, 0 divided by 5 is the same thing as 0 times 1/5.
Right.
0 times anything is
0.
0. All right. So in that case, we got x equals 0. Let's see the next one. 4 minus 2x equals 10. 4 minus 2x is equal to 10. What do we do first? Subtract 4 from both sides. Good. So minus, it's written over here. 4 minus 2x, that was equal to, was it 10? 10? All right, so minus 4 from both sides. And what do we get? Negative 2x is equal to 6. Now what do we do?
Now you're going to divide
By
2.
2 or negative 2?
Negative 2.
Negative 2. Whatever's right there, divide by it. Negative 2, negative 2. Negative 2 over negative 2 is?
X.
Well, negative 2x over negative 2 is x, but negative 2 over negative 2 is 1 times x is just x. Is equal to 6 divided by negative 2. Negative what? 3 or negative 3?
Negative 3.
Negative 3. Because that's the same thing as a positive times a negative. It's 6 times negative 1/2. That's the same thing as 6 divided by negative 2. Okay, so x equals negative 3 for that. Should be the answer. Yay. All right. Next one. 8 minus x equals 2. What are we going to do? Subtract 8 from both sides. And what do we get?
Negative x equals
Equals negative 6. Okay, now what?
you're going to divide by divide by negative 1, which is implied that x.
Perfect. Remember that negative x, we can think about this as negative 1 times x if we want. Negative x, negative 1 times x, same thing. Right? So we're going to divide both sides by negative 1. And so x equals 6. Obviously, if negative x equals negative 6, then x equals 6. Makes good sense? Okay. Oh, they do have a place where they give a bunch in one go. All right. Let's try to just think these through without writing them out. So, what am I going to do first? Can you all see this?
Yeah.
Negative 3x plus 7 equals negative 8. What do we do first?
Subtract 7 from both sides.
Subtract 7 from both sides. So we get negative 3x equals negative 15. Subtract 7 from both sides. Then what? Divide by negative 3. And what do I get? X is equal to 5. Now remember, you can always check your answer. Right? Just plug it back in. What's negative 3 times 5? Negative 15 plus 7.
-8.
Negative 8. It worked. It should always work if you did it right. If it didn't work, you made a mistake. So that's a quick way you can always check. Did I screw up my signs? Just plug it in real quick. All right, let's do the next one. What do we do first?
Add 2 to both sides.
Add 2 to both sides, so we get 9x equals 9, or in other words, x equals
1.
1. If 9x equals 9, divide both sides by 9, we get x equals 1. All right, last one. If 8 equals 2x, what do we do first?
-10.
Minus 10 for both sides, so this becomes
2.
negative 2 is equal to 2x.
You'll get 1.
So x is equal to what? Negative 1. Divide both sides by 2, and you get x is equal to negative 1. One more thing I'm going to point out. The author doesn't really specify it. Maybe he does later, I don't know. Sometimes people hate when the x is the term that's negative. So let's say I have, for example, negative 3x plus 2 is equal to, let me think. I'll make this 7. Let's imagine we had a problem like this. Sometimes people hate dealing with the negative 3x. They want to deal with the positive 3x instead. So what a lot of people decide to do as a first step is instead add 3x to both sides. Negative 3x and 3x cancel out, leaving me with just 2 is equal to 7 plus 3x. And then you do it the way you would have always done in love. Now subtract 7 from both sides and divide by 3.
Does that just make more work?
It does make more work. Yes. Some people are scared of the negative sign in front of their x term, so that's the first step that they do. Common first step people do. It just makes more work for you. If you're not afraid to deal with the negative sign in front of the x, fantastic. Don't worry about it. But that is a step you can do if the negative x is scaring you. Okay. Let's look at these ones. Oh, these aren't equations he's solving. He's giving you an example of equations that are not linear. So we're dealing with linear equations. These are a bunch of equations that aren't linear. This has an x squared term, so it's not linear. This has an x in the denominator. That's the same thing as x to negative 1, not linear. This has an x under the radical, not linear. This is taking the logarithm of an x, not linear. So these are not the types of equations you're supposed to solve yet. It's going to be nice, simple, ax plus b equals c type equations, linear equation. So he's just trying to give you intuition for what a linear equation is there. Okay, and then practice problems. Next, what are we doing? Solving linear equations in general, meaning we don't always give it to you in some pretty form. So let's solve one in an ugly form, like he has here. So 4 times 2x minus 6. 4 times 2x minus 6 is equal to 16. Okay, so what are we going to do first? Distribute the 4 throughout this thing. So 4 times 2x is equal to 8x. 4 times negative 6 is equal to negative 24. Everyone good with that? That's the 4 distributing through there? Good?
Yeah.
This is equal to 16. Okay, now what do we do? Now it's in the form we know and love. So we're going to add going to add 24 to both sides.
Yes.
Or subtract negative 24, however you want to think about it. And then we'll divide by 8. So add 24 to both sides.
You get 8x.
You get 8x is equal to 40. Okay, now what?
Divide both sides by 8.
Divide both sides by 8, and we get x is equal to
5.
x is equal to 5. Fantastic. X equals 5. All right. Let's try another one. Next one, we have 3 times 2x minus 4.
9 plus 9 equals 15.
Okay. What are we going to do first?
Distribute.
Distribute. That works. So we're going to distribute the 3 to each of these terms. So multiply by that, and multiply into that. 3 times 2x gives me 6x. 3 times minus 4 gives me minus 12. We still have the plus 9 equals 15. Now what do we do?
You're going to add your negative 12 and your 9.
Yeah, we call that combining like terms. You did a whole section on combine like terms. So combine like terms before you start manipulating your equation. So we get 6x, negative 12 plus 9 is?
Negative 3.
Minus 3 equal to 15. Now we add the 3, right? And so we get 6x is equal to 18. Now what? Divide by 6. And we get x is equal to?
3.
All right. X is equal to 3. All right. Let's see if there's any that look fun to do. This looks like a more complicated one. Let's do it. Okay. So now we're going to do this one. It's an equation where we have x's on both sides. Uh-oh.
Oh, these are so much fun.
Equals 6x minus 27. Glad you enjoyed it. All right. So what are we going to do?
Add 3x to both sides and then add consider both sides so that you get.
Okay, do one step at a time. So minus 9, both sides.
You got the right idea. Get all your x's on one side and all your constants on another side.
Right.
Right. So that's what she's saying. Quite like terms. So we're going to put all, she wants to put all the x's over here and all our constants over here.
Okay.
So we're going to add 3x to both sides. And we're going to add 27 to both sides, right?
Right.
If we're okay with doing 2 steps in one go? All right, so over here, negative 3x and 3x go out, leaving us with nothing. 9 plus 27 is 36, good. Is equal to, those go out, so we're just left with 9x. Great. And now what do? And we get x is equal to 4. Good. All right, let's do this one. So we have 2 times x minus 5
plus 3x equals x plus 8.
Okay. What are we going to do first? Distribute your 2 first. So 2x minus what?
Negative 10.
Minus 10. Then we still have plus 3x equals x plus 18. Now what do?
Combine like terms.
Combine like terms. We have 2 x's here and 3 x's here. So how many x's do we have?
5x.
We have 5 x's. Right. So 5x minus 10 is equal to x plus 18. Now what do?
Add 10 to both sides and minus 1 extra.
Perfect. We're going to minus x from both sides and add 10 to both sides. Minus x, add 10. Y minus x, to get rid of the x's over here. Y plus 10, to get rid of the constants over here. So 5x minus x leaves me
4x.
4x. Negative 10 and 10 cancel out, leave me 0. Is equal to x and negative x leave me 0.
28.
28. Or in other words, x is equal to 7. Great. All right. I think we've done enough of those. Maybe, I don't know, is that one more complicated?
No.
It's somewhat more complicated. We'll do this as our last one for this section and move on. Okay, so right down here. So 4 times 2x minus 6 plus 9 equals 3 times x minus 7 all plus 8x. What's our first step?
Distribute.
Distribute. So 4 and 2x gives me 8x minus 24 plus 9 is equal to
3x.
Plus 8x.
perfect. Combine like terms on both sides. Over here we have 8x, negative 24, and positive 9 gives me.
Didn't say it. It's so simple.
Come on.
Negative 17.
No,
No, it's negative 15.
negative 15. All right. Is equal to, how many x's do we have?
11 x's.
We have 3 here and 8 there for a total of 11.
There's two numbers.
I see. All right, minus 21 still. Okay, now what do we do?
You're gonna minus 11x.
Probably easier to minus an 8x from both sides. So we get our x's over on this side and our constants on this side.
So minus 8x.
So we're going to minus 8x from both sides. Now we'll put all our x's over here.
On both sides.
We're going to add 21 on both sides.
Oh, right.
I want over here to only have x's and over here to only have constants. So then we add 21 as well. All right, so 11 minus 8 gives me, come on,
3.
3x. Negative 21 plus 21 is?
0.
Oh, thank goodness. That's the whole reason we did that. 8x minus 8x is?
0.
Fantastic.
Six.
Negative 2. So that gives me x is equal to?
Divide by it's 2.
2. Yeah. Divide both sides by 3. X equals 2. Fantastic. And then he says you can plug it back in to check. Okay, he gave a lot of examples of that. We don't need all those. Okay. Section 1.4, dealing with fractions.
Oh. Yeah.
All right. Fractions do not change the principle in any way. We're doing the same process, just with fractions now. So we have 3/4 x
Minus 7/2 equals 5/6.
What's the first thing I do?
Add 7/2 both sides.
Add 7/2 to both sides. Same as before. So we add 7/2 and we add 7/2. Right. Maybe I'll just write it. Add 7/2 and we're adding 7/2 over here. Okay. Now 7/2 and minus 7/2 leaves me
0.
0. So on this side we're left with 3/4 x. Okay. Now over here we have 5/6 plus 7/2. If we're going to add those together, got to go back to how do we add fractions together? Find a common divisor. What's the common divisor or common denominator of these two?
3.
4.
2 or 8.
I need these. Think about as slices of pizza. 12 would work. No. If I have 5/6 of a pizza, can I express that in halves?
No.
No. If I have 7/2 of a pizza, can I express that as sixths?
No.
Yes.
If you've already cut your pizza in half, can you still cut it into sixths?
Yeah.
Yeah. Your common divisor here is 6. All right. All right, so we have 5/6
Times both by 3. Times 7 by 3. 2 by 3.
Yes.
That leaves you with 21 over 6.
So 7/2 expressed as 6. How can we do that? We're going to multiply this term by 1. We're going to multiply it by the 1. That gives us a 6 in our denominator. What's the 1 that will give us a 6 in our denominator? 3/3. So I took a number and I multiplied it by 1. Multiplied by 1 doesn't change the number. I'm just re-expressing it. If I told you that you had 7/2 of a pizza, I say, now how many sixths of a pizza do you have? You have 7/2. Now you want to come into 6. How many pieces would you have? You can't do that. You take each half and you cut it into thirds. Right? And you would be left with, this is 5/6 plus 7 times 3 is
21.
6. So 7/2 of a pizza is the same thing as 21/6 of a pizza. Okay. Now if you have 5/6 and you have 21/6, what do you have?
26, 6.
26/6. Fantastic.
Reduce.
That's a lot of 6. All right. So this is equal to 26/6. Good?
Yeah.
All right. Now, we have a number times x is equal to a number. What do?
Subtract.
No, you
No,
divide.
You divide.
You
If I have ax
Yeah,
is equal to
yeah,
b,
yeah, I get that.
we multiply both sides by 1 over a. Or in other words, we multiply both sides by a's reciprocal.
Right, so 4.
So I'm going to multiply both sides by 4 over 3. Good. I'm going to divide by 3/4 or multiply by 4 over 3. Same thing. The whole trick is I need this to turn into a 1. So multiplying by 4/3 makes that a 1. Multiply by 4/3 over here. Now 4/3 times 3/4 is equal to, how'd you do that?
cancel it out.
Just cancel it out. That's the whole reason we chose 4/3. Because it's a number that when you multiply by 3/4 you get 1. That's why we chose it. This is the exact same thing as 3/4 divided by 3/4. 3/4 over 3/4. Any number over itself is 1. A over A, 1. X over X, 1. 3/4 over 3/4, 1. Okay, so that's going to leave us a 1 over here, so that we just have x by itself is equal to. Yeah, we should have reduced this first, sorry. Let's reduce that 26/6 and then come back and plug it in. So 26/6 is the same thing as what? You can take out a 2 top and bottom.
3. 13 over 3.
13 over 3. This is the same thing as 13 times 2 over 3 times 2. Right?
Yes.
And then so you can cancel out those 2's. And you're left with 13 over 3. So let's rewrite this as 13 over 3 over here. That'll make our math work out a little bit better. Okay. So now what's our answer? What's 13 times 4? You can do it. I believe in you.
13.
Try again.
6.
52.
Yeah.
40 plus 12. Right?
Right.
I don't know how you guys think about it. We're doing 13 times 4. 4 times 10 is 40. 4 times 3 is 12. 40 plus 12, 52.
Oh, I was
You
going
were
the other way.
doing it.
Yeah, I was going
I
the other
started
way. 4 times 3 is 12. 4 times 1 is 4. Add the 1 is 5.
I just went
You can just count it up, whatever you got to do. All right. So 13 times 4 is 52. 52.
What the heck, guys?
3 times 3 is
9.
9. What the heck, guys? We got it.
And that is. Can you simplify that?
No,
Yeah.
because if we write it as its prime factorization, this is the same thing as 2 times 2 times 13. This is the same as 3 times 3. They don't have any common prime factors. So there's nothing else can cancel. 52 over 9? Oh, that's what we got. For some reason it didn't look familiar. Okay, let's do another one. These fractions seem to be challenging you a bit, so I'll work through a few more, I think. So this time we have, that same one we just did?
3/4. No.
Okay. That's familiar. Okay, 3/4 x minus
7.
7.5 equals 5, 6.
5, 6.
Oh, that's exactly what we just did.
No, it isn't.
I think it's different somehow.
No. Least common multiple. Least common denominator.
LCP equals 1.
So he's just showing a different way to do it. He's just showing a different way to do it. Okay.
So it's the same thing.
It was the same thing. I thought it looked too familiar. Okay, that one he has a different answer, so let's look at this one. Okay, so we have 2/3 x minus 2 is equal to 3/2 x plus 1/6. Oh boy. What are we going to do now? We need to get all our x's on one side. and all our constants on the other side. Which side should we put our x's on?
On this
Right side.
On this side. Why this side?
Because it has most.
There's more x's over here than there are over here. In general, move the x's to the side with the most x's. But you can move it over to here and you would have been fine. The answer just would have been, you would have just been working with negative numbers. Okay, so we are going to subtract how many x's from both sides?
3 halves.
2/3. Minus 2/3 x.
Well, it's the same.
Minus 2, it's not the same thing. 2/3 and 3 halves are very different. If I give you 2/3 of a pizza, you don't have a whole pizza. You just have 2/3 of it. If I give you 3 halves of a pizza, that's a whole pizza plus another half. Okay. So we're going to subtract 3 halves x from both sides. And that's going to put all our x's over here. We want all our constants over here, so what else are we going to do? Add 1/6 to both sides?
Add
Minus 1/6 from both sides. Minus 1/6, minus 1/6. Let's see what we get. So 2/3 x minus 2/3 x is 0. So then we just have negative 2 minus a 6.
Right.
Is equal to 3 halves x minus 2/3 x. One 6 minus a 6 is
0.
okay, fantastic. So now we just need to combine like terms. All right. Negative 2 minus 1/6. We'll scribble that on the side over here. So if I have, remember, negative 2 is the same thing as negative 2 over 1, right?
Right.
And we can think about this as plus negative 1 over 6 if it
Would
helps.
it be 2 6?
So
What's our common denominator going to be? 6. Fantastic.
6.
So I'm going to multiply this term top and bottom by 6. So I'm going to take this term and I'm going to multiply it by 6 over 6. 6 times negative 2 is? Negative 12 over 6 plus negative 1 over 6 gives me?
Negative 13 over 6.
Negative 13 over 6. There it is. So over here we have minus 13 over 6. Now we got the harder one. We have the 3 halves x minus the 2/3 x. First off, what are we going to do with that x?
The x you say there is going to be 0.
Now that's definitely not going to be 0.
You.
One we have 3 halves, the other one we have minus 2/3.
Solution minus.
Does it? What do we do about the x's here?
It's just like minus sec 5x subtract 4x. Right?
Yeah, it's very similar. So we're just going to put the x's in the numerator. So this is no different from just looking at 3x over 2 plus minus 2x over 3. This is the exact same as this. Right? And now you can just get your common divisor the way you know and love. Common divisor is 6. So what do I need to multiply this by top and bottom? Yeah, so we take this one and multiply it by 3 over 3. 3 top and bottom. We're multiplying it by 1, so that doesn't change the number. Special 1. And we're going to multiply this by 1. Which one is it? 2 over 2. That's the one.
Right.
Okay. 3 times 3x is
9.
9x over 6 plus negative 2x times 2 is
Negative 4.
negative 4x over 6. 9x over 6 minus 4x over 6 leaves me
5x over 6.
5x over 6. There it is. Okay, so this is equal to 5x over 6. Now what do I need to do? Let's rewrite this in case that's throwing you off. That's the same thing as 5, 6, x. 5x over 6 is the same thing as 5, 6, x. Make sense? So now what do I need to do? How do I get the x by itself?
gotta subtract.
No, we're not subtracting.
Wow, you got wow.
So you times 6/5.
Times 6/5. We need to divide both sides by 5/6. Or multiply both sides by 6/5. It's the exact same thing that we're always doing. If I have AX is equal to B, X is equal to B times 1 over A. Multiply both sides by 1 over A. Multiply both sides by the reciprocal of what's in front of X. The reciprocal of 5/6 is 6/5. Perfect. So this is going to be negative 13 over 6 times 6/5 is equal to 5/6 times 6/5 is 1. 1 times X just leaves us the X. That's the whole reason we multiply both sides by 6/5 to get the X by itself. So we multiply both sides by 6/5, that gets the X by itself, and now we've got this. Oh, that came out nice. Cross cancel the 6's. So we got 1 and 1. Negative 13 times 1 is? Negative 13.
Over 5.
1 times 5 is?
5.
So X is equal to negative 13 over 5. You did it. All right, let's distribute in a fraction. That's a good idea. So now we're looking at this problem. Don't give up on me now. We have 3/2 times 5/9 X plus 4 over 27 is all equal to 3. What's the first thing we're going to do? Distribute the 3/2 through. So 3/2 times 5/9 gives me 3 times 5 is
15/18.
15/18. We still have our X plus 3 times 4 is 12. 2 times 27 is 54. Equal to 3. Fantastic. Now what do we do?
You're gonna move 12.
Yeah, we need to move it to the other side. Or in other words, we need to subtract 12 54s from both sides. But I don't want to work with 12 over 54. That's really annoying. No. I just need to cancel out common factors top and bottom. Let's reduce it. That's an even over an even. So I can obviously reduce it. So 6 over what? What's half of 54? Yeah, we're dividing top and bottom by 2. 27.
I was just waiting for this.
2 times 27 is how we got 54. 54 divided by 2 is 27. Okay. So that's 6 over 27. 12 over 54 is the same thing as 6 over 27. So a little bit easier way to work with this is 15. Let's also rewrite this. 15 over 18 is the same as what? 5/6. So 5/6x plus 6 over 27, reducing the terms. You can work with these numbers if you want. I'd rather not. Still now, we can cancel out with this. Let's do this one more time. 6 over 27, what goes into both of those?
3.
3. How many times is 3 going to 6?
2.
How many times is 3 going to 27? 9. So this is really the same thing as 2 9s. Wow, that cleaned up a lot. Isn't that a lot nicer to work with than that monstrosity? All right, now what should we do? Now that we reduced our numbers. Subtract 2 9s from both sides. I'm trying to get the x term by itself, so I need to get that off this side. I need it over here. So subtract 2 9s from both sides, and we're left with 5/6x is equal to 3 minus 2 9s. Thank you. Right? Now we need a common divisor between these two numbers. Remember, 3 is the same thing as 3 over 1. What's 9? So we just need to multiply this one top and bottom by 9. So 3 times 9 is 27. So this is really the same thing as 27 over 9. That's the same thing as 3. Just rewrote 3 a little bit different. Okay? Now 27 minus 2 is 25. So this is equal to 25 over 9. 5, 6x is equal to 25 over 9. Now what?
You times
Multiply both sides by 6/5. Now multiply 6/5 over here. And then multiply 6/5 over here. 6/5 times 5 6 is? Not 0. 1. It's 1. So 1 times x is x. X is equal to, now let's look over here. 25 and 5, those cancel out, leaving 5 and 1. Took a 5 out of the top and bottom.
30.
We can take a 3 out of both these, and what do we get?
3 and 2.
Perfect. So this is equal to 5 times 2 is? 3 times 1 is?
3.
10/3. X is equal to 10/3. We did it. Okay, last section. You're so close. Hang in there. You can do it. Okay, so this next one, they're just going to try tricking you by giving you letters rather than numbers. And it's actually sometimes easier to work with letters rather than numbers because you don't have as much reducing. So I know that m plus n is equal to p. My job is to figure out what n equals. When they say solve for n, they just mean get n by itself and put everything else on the other side.
So it's p minus
Subtract
4.
n.
That's an m.
Yeah, I realized that after I said it.
So minus m from both sides. M minus m is 0 plus n is just n, and then p minus m. That's it. N is equal to p minus m. It's that simple. That's all you're doing. They just think if they throw letters in there, they can confuse you. Don't let them be right. They're out to get you. All right. So we're solving this one for a.
Oh, so you're going to do AX.
So we have a times x minus y is equal to b. What are we going to do?
Distribute your A.
Ooh, we do not want to distribute. We have a times something is equal to b. And I want to get the a by itself. In other words, I want to get rid of x minus y on this side. Just
Can't simplify.
don't distribute. That will make it hard for yourself.
Subtract X from that side plus Y from that side.
Do what's in the parentheses and then take it off.
If you have it's ax minus ay.
Imagine for a second if I have a times square is equal to b. How do I figure out what a is? Divide by square. Right?
Right.
So if I have a times x minus y, I'm going to divide by
1 over.
I'm going to divide by
Your X minus Y.
x minus y. The other thing. We want the a divided by the other thing it's multiplied by. Okay. So we're going to divide by x minus y on both sides. X minus y over x minus y is
0.
1. It's 1.
Judas Christ.
1 times a is equal to 1 times a is equal to a.
Sorry.
So a is equal to b over x minus y. That's it. That's all we have to do. Divide both sides by x minus y. We're done. It's that easy. Don't make your life a nightmare. All right.
That's the same example, isn't it?
Same example. This time we're solving for x.
Solving
So now we have a times x minus y equals b. This time we're solving for x. Now we have to distribute. Because we don't already have x times something.
So do you distribute ax minus ay equal b?
Equals
And
b.
then you divide by
Not yet.
ax.
We have, here's the term that we want by itself, so we need to get all the other terms over here. So I need to move this to the other side.
So add by ay to both sides.
Add ay to both sides. Plus ay plus ay. Negative ay plus positive ay is going to be 0. That's when we divide it. So, over here we're left with ax is equal to b plus ay.
Now you want to subtract.
Subtract a. How do I subtract a? I want the x by itself. What's next? Divide by. If I divide both sides by ax, what am I left with over here?
Oh, my help. You're going to divide by a.
Divide by a. Divide this side by a. Divide this side by a. ax divided by a. Well, a divided by a is 1 times x is x. So x is equal to b plus ay over a. There we go. Solve for m.
Oh, y equals mx plus c. That's my favorite.
That's everyone's favorite equation. What is it?
It's the line.
This gives us a line. A line with what properties?
Straight.
All lines are straight. It has a slope of m and a y-intercept of b.
Right. So minus
We'll derive that later in this class, I'm sure. But in the meantime, we're going to now solve this for m. So I know y equals mx plus b. Trying to get m by itself. So what do I
minus
get?
b.
So minus both sides.
And I'm left with mx is equal to y minus b. Right?
Yes.
Now what do we do? We're trying to
Divide by x.
divide by x. Yeah. You're going to be tempted to say we're solving for x. No, we're solving for m. So x over x is
1
times m is
m.
fantastic. M is equal to y minus b over x. Yeah, just manipulating different expressions like this.
Wow.
Let's see. Okay, so this is giving us a surface area of some cylinder. What it looks like. Yeah, you know what a cylinder is?
Yes.
So, not the best artist in the world, but I think you'll get the picture. So we have some cylinder with a radius r and a height s. This is giving us its surface area.
Right.
We have the area on the top. What's the area of a circle? Pi r squared.
R squared.
Oh, they're only counting that once.
Yeah.
They should have 2 of them if they want all the surface area. So I guess it's like a cup. We got a cup. We only have the bottom. There's a hole in the top.
Looks like a already.
All right. So yeah, we got a cup, hole in the top. We have the one in the bottom. So the area of the bottom there, that bottom circle, is pi r squared. And now we need the area of the side of the cup.
Right. Plus I s side.
That still is not giving me the area.
Yeah.
Because it should be 2 pi r times s. I don't know what that's supposed to be the area of. Okay, they're just giving us a random expression.
Oh, we're solving for x.
All right. Anyways, guess I can't tell you what that's the formula for. Yeah, I'm going to confuse you more than I help you, trying to. So ignore everything I just said and let's go to this. We're just going to solve this for s. Right?
Yes.
So I have a is equal to pi r squared plus pi r s. We're trying to get the s by itself.
Minus pi r squared for both sides.
Perfect. So I get a minus pi r squared is equal to pi r s. Now what?
You're going to divide by pi r.
Divide both sides by pi r. Perfect. And so we're left with s is equal to a minus pi r squared all over pi r. That's all there is to it. Looks like you're doing some really fancy stuff there. Actually pretty simple, right? Most of the time it looks like people are being really smart. They're really not. It's pretty simple. I don't know. That doesn't really seem like it's all that great. Maybe this would be a good one. Let's do this one. Okay, so we got a over b plus c over b equal to e. A over b plus c over b equal to e. And we're solving for a. So we want the a by itself.
Minus c over b.
Minus c over b from both sides. Minus c over b, minus c over b. So we're left with a over b is equal to e, we'll say e over 1 minus c over b.
And then you're going to multiply.
Hold on, we want to add our fractions together. What's our common divisor of 1 and b?
B.
B. So I'm going to multiply this top and bottom by b.
So a minus. So it's going to be
EB over b. So this is going to be EB all over b.
Yes.
Right?
Yeah.
Which is the same thing as EB minus c all over b. Good?
Yeah.
Okay. Now I'm trying to get the a by itself. What do I do?
Multiply by.
B over 1. Multiply both sides by b over 1. So over here we're left with just a. Then we need to take this and multiply it by b over 1. So that's EB minus c over b. I'm going to multiply that by b over 1. Cross cancel?
Yeah.
B's go out, right?
Yeah.
And so we're left with EB minus c over 1, which is the same thing as EB minus c. Same thing. Correct. Okay, I think that's enough of that. I think you got the hang of that. So, any questions you want on lecture?
Oh, yes, I had a question. Not or it's for less.
Go ahead.
Those questions. Okay. On number 1, I had a question 29.
So we are going back to homework what?
1.1.
1.1.
29.
R over 4 equals 5 over 4.
1.1, 29. R over 14 equals 5 over 14. R over 14 equals 5 over 14. And are we supposed to solve for R?
Yes, it's just a solving equation.
So yes, we're solving for 4.
So what does R equal?
Just 5.
Has to equal 5. What over
Sorry,
14 equals
sorry.
5 over 14? Now, if you want to just go through the steps, multiply both sides by 14. Or multiply it by 14 over 1 if you want to think about it that way. 14's cross cancel, 14's cross cancel. R equals 5. Yep, that's fine. Yep, want to make sure everything makes sense. Any other questions you want to lecture?
What? 21 on 1.5.
21 on 1.5. Just look on this. 21 on 1.5. Ah, they gave you an L naught.
What's the L underscore
Yeah.
0?
It's just a different variable. So don't think about it as in any way being related to L. So they have,
It's there for no reason.
no, it's there for a reason. It's a different variable. If you ever go into like a physics class, you'll get used to working with variables where you put a naught down like that. 1 plus AT. Okay. So L equals L naught times 1 plus AT. This L naught is just a different variable. You can switch that out with an M, a P, a W, whatever you want. It's just a different variable. And so, what are we solving for?
L naught.
Yes, it's
We're solving for L naught. So what are we going to do?
We're gonna divide 1 plus 8.
Perfect. we have L naught times something equals L. Just divide both sides by that something. So we get L naught, marker's eye on me. We get L naught is equal to L over 1 plus AT. That's it. So yeah, don't let subscripts confuse you. Let's look at 20 really quick. So looking at 20, we have I equals E sub A minus E sub Q
over R.
over R.
We're solving for E sub A.
And we're solving for E sub A. So this E sub A and E sub Q, they're just different variables. That's it. It's just sometimes we run out of letters, and so we need new ways to signify new things.
We use more letters.
So you use more letters, you combine letters and combine letters with letters. Yeah, subscripts, very common to do in higher maths. Use lots of subscripts. Okay, we were solving for, was it E sub A?
E sub A.
Okay. Oh, this is a great one to do. What do we do first?
You want to get your E sub Q over R.
So there's two ways that we can do this.
Oh, you can
By
flip it
over or 1 over.
Do your reciprocal.
We could multiply both sides by R. That's one option. Or we could have rewritten this as I is equal to E over A, or E sub A over R minus E sub Q over R. So you can rewrite it like this, then add this to both sides, then multiply by the reciprocal. That's one way. But let's do it this other way, just to show you doing it once. So we had I is equal to this. First thing I'm going to do is get rid of that R. It's confusing me, having it all over R.
Right.
So I'm going to multiply both sides by R. So multiply R over here, multiply R over here. The R's cross cancel.
Yes.
So I'm left with R times I is equal to E sub A minus E sub Q.
Then you're gonna add E sub Q.
And then add E sub Q to both sides. And so we get E sub A is equal to R times I plus E sub Q. Good?
And you do what?
If I can't, I probably shouldn't be teaching the class. 17. Probably don't need to say
20
more.
minus.
Oh. You're just combining like that.
20 minus 7b is equal to negative 12b plus 30. Right?
Yeah.
Okay. What do we want to do? We need to get all our b's on one side and all our constants on another.
Add 30 on both sides and then add 7b or minus 30 on both
Minus
sides.
30.
Why don't you just add
7b on
12?
both sides. So
So-
12 is more, so you have it on that side.
You're gonna have
Which side should we put the b's on? The left or the right?
Left.
left.
The left. Okay, so we'll add 12b to both sides. Remember, negative 7b is more than negative 12b. Who's better off? The person in debt 7 grand or the person in debt 12 grand? No, you're better off in debt 7 grand. You'd rather owe me 7 grand than owe me 12 grand.
Right. Better off 7 grand.
Right. Negative 7 is a bigger number than negative 12. As a general rule, put all the b's on the side with more. Put them all on the side that has more b's. Negative 7 b's is more than negative 12 b's. All right. So we're putting all our b's over here, which means we're putting all our constants on the other side.
Right.
So what am I subtracting from both sides?
20.
Minus 20 from both sides. Perfect. So 20 minus 20,
0.
nice. Negative 7b plus 12b,
5.
5b. Negative 12 plus 12,
0.
30 minus 20.
20.
10.
And so b is equal to
2.
2. Good?
Yes.
Any other ones?
just asking.
No, because I was. You went over 21 and that helped.
Figured it out from a previous round. Okay. Anything else? Okay, I'll end the lecture and I'll start uploading it.